about the periodic table. Just 2 minutes waiting for everyone to join, and then I'll start the session. So today I'll start a new topic which is about periodic table, and every class last 15 minutes we'll discuss. I will revise acid, alkali and salts and discuss some questions from that. So basically, what is a periodic table? It's a tabular or regular arrangement of the elements in rows and columns, and highlighted the regular repetition of a property of an element. This is called a periodic table. So basically what happened, like the periodic table, this is a modern periodic table. In a periodic table, the vertical columns, these columns are known as the groups. Whereas horizontal rows, these horizontal rows are termed as a period. What is the significance of a group or a period? Like example, the blue line, the blue shade is representing the group, and the red shade is representing the period. So what group number represent? The group number shows the number of electron in last shell. So how many electrons are there in the last shell? That is represented, or that is known as a group number. Example, so this is group 1. So here if it's group 1, lithium, how many electron in the last shell? It will have 1 electron. Sodium, how many electron in the last shell? 1 electron. Potassium also 1 electron. Same thing, group 2, how many electrons in the last shell? 2 electrons will be there in the last shell for each element. Same is for group 3, 4, 5 and so on. Group 8 or 0 group element, why we call them as 0 group element? Because they have complete shells. Their shells are complete, that's why we call them as 0 group or group 8 element. Same thing, the period, what is period stand for? Period refers to number of the shells. So how many shells we are using, that is known as a period. Like example, the first period is having only 2 elements, which is hydrogen and helium. So first period means they will have 1 shell only. The second period include lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So they will have 2 shells. The third period involves sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. So how many shells will be there? They will have 3 shells. So when I take sodium, so how many, because it belongs to third period, so period represents the number of the shells. So for a periodic table, the group represent number of electrons in the last shell or the valence shell, where period represents total number of shells. So example, if I say potassium, yes Hashim? Yes?
Sir, this is the new topic, right?
And this is topic periodic table, chapter 9. I just started this topic.
Okay.
So group is representing the number of electron in the last shell and the period is representing the total number of shells. So when you check the period, the first period is having hydrogen and helium. The second period is having lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. The third is having sodium, magnesium, aluminum, silicon, and this is the fourth period. So the period represents the number of the shells. So if I say potassium belongs to fourth period, so what does it mean? It means potassium is how many shells are used in the potassium. It means 4 shells are used in the potassium. And it belongs to group 1. When you check the group, the vertical or the columns are known, vertical columns are known as a group number. So when you check its group, it belongs to group 1. So the group number represents number of electron in the last shell. So it is having 4 shells and there is 1 electron in the last shell. So using a group and the period number, you can identify the number of shells and number of electrons in the last shell. Then in a periodic table, what happened when we move from left to right? So as we move from left to right, what we observe that the nature of the element changes. On the left hand side, you will find metals, and on the right hand side, you will find non-metal. And there is another part in the periodic table which is known as a metalloid. This staircase line, which started between boron and aluminum. So the elements above and below this line are known as metalloids. Why we call them as metalloid? Because they have the properties resemble with, some of their property resemble with metals and some of the properties resemble with non-metal. Like example, when you take example of aluminum tend to lose electrons. So lose electron is a property of the metal. But when you check the aluminum, compared to other metals, aluminum, you can easily fold or you can easily apply force and mold the aluminum into different shape. So this is not the property of the metal, this is a property of non-metal. So some of the properties resemble with metal and some of the properties resemble with non-metal. That's why we call them as metalloid. So either side of this red line or staircase line, elements are known as metalloid. The blue shade on the left hand side, elements in the blue shade are known as the metals. And in the red shade, the elements are non-metals. So you have metals, non-metals, and metalloids. So moving from left to right, what we observe that the metallic character changes to non-metallic character. Or there are more metals on the left hand side and there are more non-metals on the right hand side. And what are metallic character? Means shiny. Conductivity means conducting heat and electricity. Density. Malleability means when you apply force and you can hammer something into malleable and ductile. Malleable means you can hammer them into shape, and ductile means you can stretch them into wire. So I want you to copy this part. Moving from left to right, the metallic character changes to non-metallic character. No need to make a table. You can use the book periodic table of your book and shade that to identify the position of metal, non-metal, and metalloids. So moving the idea, this is about the periodic table arrangement of element on the basis of atomic number. We call that table as a periodic table. And in a periodic table, we have metals, non-metals, and metalloids. Metals, high density, conduct electricity. Non-metal, low density, does not conduct electricity. Metalloids, their some properties resemble with non-metals, some of the properties resemble with metals. You have finished writing this? The first group is known as the alkali metals. These alkali metals, you can see here the group 1, which is also known as the alkali metal. This group includes lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements which are included in this group. As we go down the group, what we will observe, you have to learn the periodic trends. So periodic trend of group 1 or alkali metal. First thing, why we call them as alkali metal. Radioactive element means the element which is emitting out radiation is called radioactive element. So why first we call them as alkali metals? Because when they react with water, makes the solution alkaline by forming hydroxide. So whenever these alkali metals mix with water, they will make the solution alkaline. That's why we call them as alkali metal. Like example, if it's lithium and you add water, or lithium is added to water, what it will form? It will form lithium hydroxide, LiOH, and it will also give hydrogen gas. So lithium plus water gives lithium hydroxide plus hydrogen. That's why whenever alkalis form, the pH of the solution will be more than 7 That's why we call them as alkali metals. Same thing if sodium, which is Na, reacted with water, H2O, it will form sodium hydroxide, a base, and gives off hydrogen. Again, a solution is alkaline because of presence of hydroxide or OH ion. Same way, if it's potassium reacted with water, it is forming potassium hydroxide or KOH, or make the solution alkaline and gives off hydrogen. So this is metals are solid. Water is a liquid here. All acid and alkalis are, and soluble salt are aqueous. Aqueous means they will remain dissolved or contain water. And hydrogen is a gas. So what is the observation when this reaction occurs? What you will observe when this reaction occurs? Look, the metals which can displace hydrogen, you have to learn the reactivity, Salman. Your question is how you will know which element, which metal will displace hydrogen. For group 1, all the metals can displace hydrogen because they are highly reactive. But there is a reactivity series of the metal which is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. So till lead, all the elements can be reacted with hydrogen. So you have to recall the reactivity series which you took in electrolysis. So all the metals which are having higher reactivity than hydrogen can displace hydrogen from the compound. But here, because you are learning group 1, so group 1 elements are lithium, sodium, potassium, so lithium, sodium, potassium, rubidium, cesium, and francium. These are the
So
elements
that's
of
group 1 that you said right now.
what?
Are these group 1, like the
Yeah.
elements that you said right now?
You are learning group 1 element now, yes. These are the group 1 elements.
So, sir, potassium is the most reactive towards water in this group.
Potassium is?
The most reactive towards water.
No, not potassium. Francium is the most reactive. As you go down, the more reactivity increases. That I will explain why the reactivity increase. But the first thing I'm discussing why we call them as alkali metals. So first I'm discussing why we call them as alkali metals, and then reactivity I'll discuss which is more reactive and which one is less reactive. That's the second part of the explanation. But first part is why we call them as alkali metals, because they react with water and make the solution alkaline. Same thing if rubidium is there, which is Rb, reacted with water. So what it will form? It will form rubidium hydroxide plus hydrogen. So this is aqueous, gas, liquid, and solid. So what is the observation when this reaction occurs? So you will observe, number 1, the solid dissolve or solid size decrease. The solid is a metal, so its size decrease, and because the gas is given off, so you will observe phase bubbles or effervescence. Is it clear?
Sir, like when the bubbles form, if we use a francium, like it will be like an explosive, right? Explosive
Yeah, it
physique.
will be. Yeah, right.
But if
that's
we use lithium, the bubbles will be like it will not be that reactive.
The rate of formation of the bubbles is slower in lithium as compared to that of francium. But group 1 alkali metals are highly reactive, even respectively, like compared to other metals, the formation of bubble is much faster. Is it clear?
Yes, sir. Thank you.
And why the solid size decrease? Because it is reacting. Like if you have a container and this container was filled with water, and you have a solid piece of lithium which you add to this container. So because the lithium is reacting, so what you will observe? You will observe the size of the lithium, sodium, potassium, rubidium, cesium, francium will decrease because they are reacting, and as a result you will observe fizz, bubbles or effervescence. How I can test this gas? What is the test of hydrogen? Test for hydrogen. How I can test this gas?
The glowing splint, it will go pop.
Not glowing, lighted splint for hydrogen. Glowing splint is for hydrogen. Lighted splint, it will pop, produce a pop sound. Finish writing this, is it clear? The group 1 metals or alkali metals, why we call them as alkali? Because they form a solution. When they react with water, they make an alkaline solution. Finish writing this.
Yes, sir.
You can use your mic or you can use the chat to ask anything, any question related to the topic. So reactivity of the group 1, as we go down the group, what we observe, going down the group, the reactivity increases. They become more reactive. What is the reason why the reactivity increases as we go down the group? We have the element, we have lithium, sodium, potassium, rubidium, cesium, and francium. So reason why as we go down the group, the reactivity increase, because these are
The furthermore, the outermost.
yeah. So the metal, what happened? All of the, like example, lithium belongs to second period. So lithium will have 2 shells, where sodium belongs to third period. So sodium will have 3 shells. Potassium belongs to fourth period, so it will have 4 shells. And all of them having 1 electron in the last shell. Potassium, there's 1 electron in the last shell, sodium also 1 electron in the last shell, and lithium also 1 electron in the last shell. So the force of attraction, because the nucleus is pulling or attracting the electron, so the distance, as the number of shells increases, the force of attraction between the nucleus and the electron decrease, or electrons are far away from the nucleus, so it can lose electron easily. So as it can lose electron easily, it can react much faster. So as the number of the shell increases, electrons down the group electrons are far away from the nucleus or move further away from the nucleus, which increase the attraction between the nucleus and valence electron. Valence electron means the electron in the last shell, makes it easy to lose electron and increase so as the number of the shell increases down the group, the electrons are far away from the nucleus, which decreases the attraction between the nucleus and the valence electron, make it easy to lose electron, result increase the reactivity. That's why as we go down the group, the reactivity increases. Is it clear? Then another periodic trend is about melting point of group 1. So melting point, as we go down the group, what we observe the melting point decreases. So we have lithium, then sodium, then potassium, rubidium, cesium, and francium. So alkali metals or group 1 metal. Yes, you have to remember for group 1, you should know all the elements. Group 1, group 7, group 8. Only 3 groups you have to learn all the properties as well as the trend and the name of the element in sequence. But in you don't, it's not necessary you memorize, because in exam you will have a periodic table. So you can use that periodic table and you can work out. But periodic trends, you have to learn or memorize these periodic trends. So melting point, as we go down the group, the melting point decreases. What is the reason for that? Look, if the structure of the metal has a lattice of a positive ion and the free electrons, and the metallic bond is stronger. So a lattice of the metals have a strong force, but why the force is decreasing? Because lithium positive ion is smaller in size. So you will have close packing, or you will have more positive ions. Because a metallic bond is the force of attraction between the metal and the free electrons. So lithium positive ion, because lithium is smaller in size, so having only 2 shells, lithium atom, and it will form a lithium ion. So the size, but when you compare potassium, potassium is larger in size compared to that of lithium. I'm just drawing the last shell to explain the idea. And metallic bond is the force of attraction between the positive ions and the delocalized electrons. Because these positive ions are smaller in size, so if they are smaller in size, they will have greater attraction to the electron. So stronger attraction means high melting point. So positive ions are smaller in size. greater attraction towards electrons within the structure. That's why it will have high melting point. But when you compare with this potassium, so its potassium ion size is much bigger. Potassium ion size is also bigger. So if ion size is bigger or larger ion size, so there is a weak attraction. That is why it will have a low melting point. So in metals, because all these are metals, so they will have a lattice of a positive ion and the free electrons. But the lattice of the positive ion, the lithium lattice, the positive ions are smaller in size. So as the positive ions are smaller in size, they will have more attraction or greater attraction towards the nucleus. So as they have a greater attraction towards the nucleus, higher melting point, because the melting point or boiling point refers to attraction between the melting point of the, in case of metal, is attraction between the positive ion and the free electrons.
Sir, it's the same as reactivity.
Reactivity is refers to tendency to, for a metals, reactivity refers to tendency to lose electron. That's called reactivity. But metallic bond is an attraction of between the positive ion and the free electron.